Welcome back to Math 124, Introduction to Statistics. We're going to be talking about the addition rule and complements. No. Complements with an E. We're talking about completing something. Okay, look quick. And again, quick glance. And finally, did you catch that? Yes, those were your actual test grades from this semester, but you can stop the video and go back if you need to. I have limited time with each of these videos, and I have to move on. Okay, let's talk about this setup. We're going to consider the probabilities involving two events, okay? And we said an event was a collection of outcomes. So, and a sample space, which is represented here by this S, a sample space is all the possible outcomes you could have if you run a trial. Okay, so for instance, if you write these numbers on ping pong balls and put them in a big bowl and close your eyes, stir them up, and grab one, you would be randomly selecting one of these 12 outcomes. So first let's take a look at what those outcomes would be. So for instance, for A, we'll call this event A, that event would be choosing one of these even numbers, randomly choosing 2, 4, 6, 8, 10, or 12. Okay? The event B, choosing an odd number randomly from those 12 numbers, would be 1, 3, 5, 7, 9, and 11. Those would be all of the outcomes that would be odd. Okay, the event C is you choose a number that is less than 3. So there are only two ways to do that here. You can either choose 1 or 2 randomly from that set of 12 numbers. Okay, if you're looking at choosing a number greater than 10, you also have two possible outcomes, 11 or 12. If we look at event F as a multiple of 3, what are the outcomes? Well, we have 3, 6, 9, and 12. And if we look at event G, a multiple of 4, then we only have 3 of those. We have 4, 8, and 12. Okay? So remember those numbers. We're going to talk about something a little different now. All right? We're going to talk about the probability of drawing those numbers. Right now we just listed the possible outcomes that would be part of that event. So what's the probability that that event occurs? And we write those probabilities symbolically this way. We say the probability of A. Well, there are 6 ways to choose an even number, 2, 4, 6, 8, 10, or 12. And there are 12 possible numbers that we could choose. So the probability of choosing an even number is 1/2, or the way we're going to express it today, 0.5. And today I think we're going to go out to the thousandths place, so we can just add 2 more zeros so that all of our probabilities are expressed to the thousandths. All right, the probability then of choosing an odd number. Okay, the probability of B would be the same as the probability of A, 0.500. Okay, probability of choosing an even number is 1/2. The probability of choosing an odd number is 1/2. What is the probability that out of those 12 numbers you will choose an even or an odd number? That's all you can choose, one or the other. So the probability would be 1. And here we have found our first complement. B is a complement of A because it, in a way, completes the set. Anything that is not in A is in B. Therefore, they are complements, and everything that is not in B is in A. So you can say it either way. A is also a complement of B. And the probabilities of any two complements will add up to be 1. But later we will talk more about complements. Okay, let's talk about the probability of C, drawing a number less than 3. So there are two ways to do that. Out of the 12, that's equal to 1/6, which is equivalent to 0.1666, going forever, so we will just stop here and we'll need to round up. All right, and the probability of D is also 2 out of 12, or 1/6, or 0.167. All right, and the probability of F, I skipped E. Why do you think I skipped E? Well, we use E for any event in general. And I'm giving these different names because we're working with the same set, and so I'm giving them the events different numerical names. So therefore, the probability of F is, there are 4 ways to choose a multiple of 3, and that's out of 12. So we're looking at 1/3, or 0.333 repeating, and we can just stop right there. Okay, and finally, the probability of G. Multiples of 4, that would be 4, 8, and 12. That's 3 possible numbers you could draw from the 12. That's equal to 1/4, or 0.25. And we'll throw another 0 on the end there to take it to the thousandths place. Okay, that's cleaned up a little bit. I think I want to get a little bit bigger, though, if I can do this. Okay. So let's take a look at what happens when you start combining these things. And we're going to look at something called Venn diagrams, because they can illustrate how you can combine different events. I am going to draw a rectangle here, well, kind of a rectangle. All right, pretend that's a nice, pretty rectangle. And this is going to represent the sample space, S. All of our numbers will be inside of here. So we'll have like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, that's all of them, right? Okay, there are all of the numbers inside our sample space, S. And now all of the even numbers represent event A. Okay. And let's see, let's take a look at event D. All of the numbers greater than 12. So now we have something interesting that we can use to talk about what happens when you're looking at the probability of A and D. Okay? The probability that a number is both even and greater than 10 within this sample space. And there is only one number that is both even and greater than 10, and that is 12. So there is one way that can occur out of all 12. But doesn't it seem like that would be related in some way to the probability of A and to the probability of D? And by the way, as a decimal, that would be represented 0.083. Very small compared to the others. All right, while we are here, let's look at the probability of C and D. Okay, so the probability that you can draw a number from here that is both less than 3 and greater than 10. So let's see, the ones that are less than 3 are, this is going to be a funny one. Okay, they have to be enclosed by that green line. And then D is greater than 10. So that's there. And the number that is both of those is nothing. So the probability of that occurring is 0. It's impossible. And another way we could describe C and D is to say they are disjoint. That means they have no numbers, no outcomes in common. They are disjoint. But what about the probability of C or D? What would happen there? What would that be equal to? Okay, if it's C or D, there are four numbers that are either less than 3 or greater than 10. So that would be 4 out of 12, or 1/3, or 0.333. Okay? For disjoint events, the probability of both of them occurring at the same time, if you're drawing a number that fits both events, is 0. But the probability that it is one or the other, in this case less than 3 or greater than 10, that is a completely different probability, and there's actually a rule of probabilities that we can use in this case. Here is the addition rule for disjoint events. If event A and event B are disjoint or mutually exclusive events, then the probability of A or B occurring is just the probability of A plus the probability of B. And if you want to combine more events, you can say the probability of A or B or C or whatever, as far as you want to go, is equal to the probability of A plus the probability of B plus the probability of C, as far as you want to go. So don't get hung up so much on the letters. If we let a number being less than 3 be A in this case, then the probability of A is 2 out of 12, and the probability of B being a number greater than 10, event B, would be 2 out of 12. And if we add those together, we'll get 4 out of 12, or 1/3, which is equal to 0.333. It's often better, if you can, to leave them as fractions before the final addition, and then you won't have rounding errors. You won't compound your rounding errors, at least. Now please remember, this is the addition rule for disjoint events, the events that have no outcomes in common, that are mutually exclusive. Those are all different ways to say the same thing. Another disjoint event in this sample space would be the event that the number equals 7. Only one outcome in that event, but it is still disjoint from the other two, and you could figure out what the probability that it is A or B, or we'll call this one C, and you would just add 1/12 to what you had before. But it's time to wrap up this video. Please look for Part B coming soon.